Welcome to the deep dive. Today, we're really unpacking something fundamental for anyone who gets behind the wheel. We're talking about those everyday things: accelerating, braking, turning,
Right.
maneuvers that feel, almost automatic, but they're actually shaped, profoundly shaped by
Yeah.
this powerful sort of invisible force, momentum. And look, this isn't just academic physics chat. Understanding momentum is, well, it's a critical layer of knowledge. It directly impacts your safety, your control.
Especially when you're moving faster?
Exactly. Or if you're driving something heavy. So for this deep dive, we're going to tackle questions like, what really happens to your vehicle's momentum in, say, a collision? And can the sheer weight and speed of your vehicle actually make braking drastically harder than you might think?
That's absolutely the goal, yeah. Our mission today is to break down the physics of momentum in really clear, actionable ways, relating it directly to your real-world driving. By the end of this, you won't just know the definitions, you'll get how momentum interacts with your brakes, your steering. It should help you anticipate your vehicle's behavior better and hopefully make smarter, safer decisions out there on the road.
Okay, so let's peel back the layers then.
Yeah.
When we talk about momentum, what is it really? At its core,
hmm
our sources sometimes call it the quantity of motion. What does that actually mean?
Yeah, quantity of motion is a good way to put it. Imagine trying to stop a bowling ball rolling towards you compared to, say, a tennis ball. Even if they're moving at the exact same speed, the bowling ball has just so much more, well, quantity of motion because it's
Okay.
heavier, right?
Yeah.
That's momentum. It's basically how much oomph your vehicle has built up. And the math is simple. Momentum, usually P equals mass times velocity V.
That bowling ball analogy really helps.
Yeah.
So the more oomph it has, the more effort and, importantly, distance it takes to change what it's doing, like speeding up, slowing down, or even turning.
Precisely. More momentum means it's harder to change its state of motion. And this is where it gets, well, really interesting and maybe a bit counterintuitive for some folks. We all kind of know that doubling your speed means you need more room to stop, right?
Sure, yeah.
But the physics behind it, specifically kinetic energy, that's the energy of motion, it actually increases with the square of your velocity.
The square. Okay, so not just double.
No, not double. So if you go from, say, 30 miles per hour to 60, you've doubled your speed, but your car now has 4 times the kinetic energy that the brakes need to dissipate,
4 times. Wow.
which means you need 4 times the stopping distance, not just twice as much. And that's a fundamental shift in how you really need to think about speed and safety margins.
That's a huge point. 4 times the stopping distance, not double, when you double your speed. Okay, so if velocity has such a dramatic squared impact, what about the other big piece of that momentum equation? Mass. How critical is that for drivers?
No, it's equally critical. Mass is the other side of that coin. While velocity dictates how much oomph you have at a given speed, the actual weight of your vehicle, and crucially anything you're carrying, directly scales up that momentum. Simply put, the heavier you are, the greater your momentum is at any given speed.
Right. That makes intuitive sense. Can you give us a really vivid, maybe a real-world example of just how much difference mass makes in stopping distance?
Absolutely. Let's picture a fully loaded semi-truck, a big rig, even if it's traveling at the exact same highway speed as a small passenger car. That truck needs substantially more distance to come to a complete stop. We're talking maybe the length of 2 football fields for the truck compared to perhaps 1 for the car. It's a massive difference.
It's 2 football fields.
Yeah. So the takeaway for you is if you're pulling a trailer, or maybe your SUV is packed full for a family vacation, you've significantly increased your mass. You immediately have to adjust. Driving a bit slower, leaving much more following distance. It's not just, good advice. It becomes a physical necessity because of that increased momentum.
So mass and velocity are the big two, definitely. But our sources mention some other factors too. Are there other things, maybe less obvious ones, that influence momentum?
Yeah, there are. Beyond the core M times V, even the direction you're traveling matters. A vehicle moving in a straight line tends to, let's say, carry its momentum more efficiently than one that's constantly turning or curving. And of course, your actions have a direct impact. Braking actively reduces momentum, obviously. Acceleration builds it up, sometimes quite rapidly.
Okay, that makes sense. But what about external things, like the road surface itself? How do things like rain or ice play into this momentum picture?
Road conditions. That's huge. Think about a wet road, or worse, an icy one. Your tires might be trying their best to grip, maybe your ABS is even kicking in, but if there's very little traction, that large amount of momentum you've built up just keeps you going. The tires simply can't generate enough friction to counteract it, to dissipate that energy effectively.
So momentum still rules, even with fancy brakes, if the tires can't grip.
Exactly. Momentum is still king, especially on slippery surfaces. It's a stark reminder of the limits of technology when faced with basic physics.
Now, something that often trips people up, myself included sometimes, is the difference between inertia and momentum. We've talked a lot about momentum. How does inertia fit in? Are they the same?
That's a great question, and yeah, they're often confused. They're related but distinct. Inertia. Inertia is an object's inherent resistance to any change in its state of motion. Think about when you brake hard. Your body wants to keep moving forward, right? Even though the car is slowing down.
Right, that lurching
Yeah,
feeling.
that's inertia. It's the tendency of any object with mass to just keep doing what it's doing, whether that's staying still or moving at a constant velocity, unless some external force makes it change. It's a property of matter itself. Momentum, on the other hand, as we've been saying, is the measure of motion. It quantifies it. It's the mass times the velocity. So inertia is the resistance to change, while momentum is the quantity of the motion that needs changing. You need to understand both, really, to get the full picture of vehicle dynamics.
Okay, that distinction is helpful. Inertia is the resistance, momentum is the amount of motion. So let's bring this all together for the listener. How does knowing all this actually empower you when you're driving?
Well, the power here is in anticipation and control. Knowing how mass and speed affect momentum, understanding that stopping distances increase dramatically, it's absolutely key to maintaining control. It helps you choose safer following distances, anticipate stops much earlier, and just generally be more prepared for what your vehicle might do or what it can't do quickly.
So it's less about knowing the formula itself and more about internalizing the implications, like understanding why you need that extra space or why taking that corner too fast is risky.
Exactly. It's about translating the physics into practical defensive driving. There's a reason experienced truck drivers look much further down the road than most car drivers.
Yeah.
They're not just spotting immediate hazards, they're constantly calculating. They're managing the immense momentum of their rig, thinking about the space and time needed for even small adjustments, let alone emergency stops.
That's a great point. So for the average driver, this translates into leaving more space, being smoother with inputs, and just generally driving more defensively.
Precisely. By understanding how momentum impacts your car's handling, its stopping ability, you can genuinely make smarter, safer choices. It's not about being scared, it's about being informed. This knowledge really does give you the confidence to see potential hazards developing earlier and avoid them before they become, truly dangerous situations. Whether you're in city traffic or out on the highway, it's about driving with foresight.
And really, there you have it. Understanding momentum, it seems, is a powerful shortcut to becoming a more informed and definitely a safer driver. You've hopefully gained some key insights today into how your vehicle truly moves and reacts.
So, maybe a final thought to leave you with. Given how much momentum impacts control and safety, how might this deeper understanding change the way you look at things next time you're driving? How might it change how you judge speed or the distance you leave to the car ahead? Something to ponder.
Definitely food for thought.
Okay.
Thank you for joining us on this deep dive. Drive safely, everyone.
Please like, subscribe, and get notified.